Well, this is the engine off the Cub, this Super Cub. This is a Lycoming 0360 C4P. It's a horizontally opposed engine, 4-cylinder. This is a crankcase here. It's cast in 2 halves, and the camshaft is on the upper side here, and the crankshaft is in the middle. Of course, comes out here on the front. And then it has 4 individual cylinders here mounted to the side of it. Each one of them are individual. Each one's are mounted up separately. It's an air-cooled engine. It has this baffling around it and then a cowling that goes over it that this baffling seals up in the cowling, which there's openings here in the front. Air comes through and goes around the fins of these cylinders and then out the bottom to cool it. I think this crankcase is cast aluminum. And then some of the stuff, like the sump on some airplanes, the oil sump bolts up to the bottom. That's like an oil pan in a car. Some of those are cast magnesium. And then there's an accessory case on the back that runs off of gears. And that turns gears for the magnetos. And then you have a vacuum pump that can be put on back there to supply air, or suction actually, for instruments in the airplane. It has an oil pump back there. The other accessories can mount to that back there. This engine has a solid crankshaft. There are some engines that have a hollow crankshaft and they build up oil pressure inside the crankshaft that comes out into the propeller to control the propeller, a constant speed propeller or a variable pitch propeller. This one has a fixed pitch propeller that mounts onto it. And there's an alternator here that runs off of a V-belt, off the flywheel or off the ring gear. And then there's a starter that mounts on the other side. Carbureted engine, the carburetor is down underneath. The cylinders are steel, and then there's heads on here that are aluminum, and the heads are machined out to a smaller diameter and threaded. They thread onto the barrels, the steel barrels, but they're machined out slightly smaller than the barrels, and then they're heated up and the aluminum expands, and then they're fitted on there, so they actually become almost one piece. It might be considered an overhead valve engine because it has valves in the head. There are 2 valves, and there are 2 spark plugs, one spark plug in the top and one in the bottom, so you can get a uniform flame front, and it maximizes the power that you can get out of the engine. I think there are something like 100 different iterations of this engine that Lycoming puts out. There's some, like I said, with a hollow crankshaft. There's some fuel-injected engines. There's fuel-injected turbocharged engines. There's engines that turn left. This one turns clockwise. There are some that turn counterclockwise. Those are generally used on twin-engine airplanes, so you can have propellers that rotate into the airplane to minimize P-factor, asymmetrical thrust, when you have an engine out on a twin-engine airplane. So there are some left-handed engines that run on pusher airplanes, airplanes that have the engine in the back with a propeller on the back that push instead of pull. There are helicopter airplane engines, engines that are made to run vertically instead of horizontally like this. I don't know whether the 0320, which is a 150 horsepower engine, uses the same crankcase as this or not. I think it does, and just uses different cylinders. So they have different sizes of bores and different strokes on them. I think these are different stroke on these, so they're a longer stroke in the piston. I haven't studied them enough to figure out all the differences in them. And then, of course, you can use the same cylinders on a 6-cylinder engine. There's a 540, a Lycoming 0540 or IO540, that basically everything is the same on except the crankcase is longer and it runs 2 more cylinders on there. So we round up with a problem on this engine. When I was getting ready to put the spark plugs back in, I decided to go ahead and do a compression test on it, and the engine wouldn't turn over. So it must have got moisture in it, condensation in it, and seized up the cylinders on there. I lubed it, oiled it, and got it to turn, but I'm not going to run it like that. So my mechanic has got 4 new cylinders, actually has 3 old cylinders that he was overhauling down there in Washington, that I called him, and he's going to finish overhauling those and bring them up with him. So we'll change the cylinders on it. So changing the cylinders, basically there's 4 bolts on the top, 4 bolts on the bottom. Then you got to take the intake off and the exhaust off, and the thing comes off. Of course, you have to take the baffling off too to get it off there. And then the cylinders slide off. These push rod tubes here are separate from the cylinders, and they have push rods in here that run up to the lifters, from the lifters to the rocker arms up in here in the head. I had 4 cylinders that we change out as necessary. This is one of them we've carried. It was rebuilt and was carried as a spare. And I've had it in the soccer shed there for several years in the box. So I pulled it out to check it out to see how it was. Since these were rusted up, I wanted to check that one before we needed it. It was nasty. Whoever had overhauled it didn't really overhaul it. They might have honed it out and put new valves and did the valve job on it, but he didn't clean out the carbon on it. So there was grungy carbon. The piston was in there with new rings in it. It was just packed with carbon in there between the piston and the cylinder, and back up inside the cylinder, and around the valves, and in the valve ports here is just full of carbon and crap. So I was looking at cleaning that up, but one of the things that I found on that when I got to looking at it was here at the top of where this piston was in the chamber, in the cylinder here, the carbon that was in there somehow reacted and it's embedded or stuck into the cylinder wall. What I have to do with this now is to hone this cylinder and see if we can make it usable. I called Jim and told him what was going on, and he's looking for another cylinder, but meanwhile I'll see if I can salvage this one. So I'll need to pull the valves out of it, and to do that I'm going to have to make a plug, a wooden piece. I just have to whittle out a round wooden piece to fit in there that I can put the cylinder down over to hold those valves. And then I've got a valve compressor that I can hook underneath this pin for the rockers and compress this spring down and take those valves out, and then I can clean that all up. Once I do that, then I'll see if I can salvage that cylinder. I'll run the hone through it and see if I can salvage that cylinder. Now I also have to take the rings off of the piston. This piston was just nasty. There's grungy, there's crap all over it. I've got it somewhat cleaned up right now, brushed off, but I've got to take these rings off, and I've checked these rings and they appear to be new rings. I don't feel any knife edge on them or anything like that where there's any wear on them, but this thing was just nasty. So I've got quite a bit of the junk cleaned out of inside here already, but I've got to do some more, and I'll have to pull those rings out to make sure those ring grooves get cleaned out of there, because anything that's in there can interfere with the rings turning in the groove or compressing completely. Well, that's not something I was looking forward to. I need something in there to hold those valves while I compress those springs to get the valves loose. I went out to the woodshed and found a piece of firewood that was about the right size. Took the axe and split it out, roughed it out in the approximate diameter, and then I took the hand axe, a little hatchet, and tapered it up here on the top so it fit in that compression chamber. The cylinder is about 5 inches in diameter, but then it rounds out in the head there in the compression chamber. I had to do a little bit of shaping with it with a hand axe once I got it. I'll slide that right down over that, and then that can hold those valves while I get the spring compressor. Well, I've got a little pin that goes in there. You don't want to use the regular rocker pin, damage it. So there we go. I had to go down a little ways to get that. Now let's see what happens here. I got to be able to hold that cylinder down. There we go. Need a hold down plate. Alright, so there's one keeper. And there's the other one. off of there. Painless. Okay, lift it up slow so it doesn't disappear into the ether. And there we go. Well, now the valves can come out. I can just pick that up. And just take the valves out. There we go. Now I can clean that cylinder up and run the hone down that cylinder and clean out those intake and exhaust ports.